Introduction to Systems Development and Systems Analysis. Introduction. Because we live in a highly competitive and ever-changing world, at any given time most organizations are improving or replacing their information systems. Companies change their systems for the following reason: change in user or business needs. Second, technological change. Third, improve business processes. 4, competitive advantage. 5, productivity gains. 6, system integration. And the last, systems age and need to be replaced. System development. The 5-step system development life cycle, or SDLC, shown in figure 21 and briefly explained here. Here are the system development life cycles. There are system analysis to conceptual design to physical design, and then go to implementation and conversion, and operation and maintenance, and go to system analysis again. System analysis. System analysis. The first step in system development is system analysis, where the information needed to purchase, develop, or modify a system is gathered. Conceptual design. During conceptual design, the company decides how to meet user needs. Physical design. During physical design, the company translates the broad, user-oriented conceptual design requirement into the detailed specification used to code and test computer programs, design input and output documents, create file and databases, develop procedures, and build control into the new system. Implementation and conversion. All the elements and activities of the system come together in the implementation and conversion phase. And operation and maintenance. During operation and maintenance, the new system is periodically reviewed and modifications are made as problems arise or as new needs become evident. The player. A number of people must cooperate to successfully develop an implementation and AIS. Management. Most important system development roles are to emphasize the importance of involving users in the process, to provide support and the encouragement for development projects, and to align system with corporate strategies. User. AIS users communicated their information needs to system developers. Information System Steering Committee. An executive-level information system steering committee plans and oversees the information systems function. Project development team. Each development project has a team of system analysis and specialists, managers, accountants, and users to guide its development. And still the players. System analysis and programmers. System analysis help users determine their information needs to study existing systems and design new ones and prepare the specification used by computer programmers. Computer programmers write and test programs using the specification developed by system analysis. They also modify and maintain existing computer programs. External player. Customers, vendors, external auditors, and governmental entities play a role in system development. Planning system development. Planning has distinct advantage. It enables the system's goals and objective to correspond to the organization's overall strategic plan. When development is poorly planned, a company must often return to a prior pace and correct errors and design flaws. This is costly and results in delays, frustration, and low morale. 2 system development plans are needed. Project development plan. A project development plan prepared by the project team contains a cost-benefit analysis, developmental and operational requirements, and a schedule of the activities required to develop and operate the new application. Master plan. Along range master plan prepared by the Information System Steering Committee specifies what the system will consist of, how it will be developed, who will develop it, how needed resource will be acquired, and where the AIS is headed. Here are the reasons for returning to a prior SDLC phase. Planning techniques. The program evaluation and review techniques require that all activities and the precedence and subsequent relationship among them be identified. Completion time estimates are made and the critical path, the path requiring the greatest amount of time, is determined. If any activity on the critical path is delayed, then the whole project is delayed. If possible, resources can be saved to critical path activities to reduce project completion time. Feasibility analysis. A feasibility study or business case is prepared during system analysis and updated as necessary during the SDLC. The extent varies. For a large-scale system, it is generally extensive, whereas one for a desktop system might be informal. The feasibility study is prepared with input from management, accountant, system personnel, and user. There are 5 important aspects to be considered during a feasibility study. First, economic feasibility. Second, technical. 3, legal. 4, scheduling. And 5, operational feasibility. Capital budgeting, calculating economic feasibility. During system design, alternative approaches to meeting system requirements are developed. Too often, companies overspend on technology because its costs and payoffs are not measured and evaluated like other corporate investment. In a capital budgeting model, benefit and costs are estimated and compared to determine whether the system is cost beneficial. Benefit and costs that are not easily quantifiable are not estimated and included. The following are 3 commonly used capital budgeting techniques. Payback period. The payback period is the number of years required for the net saving to equal the initial cost of the investment. Net present value or NPV. All estimate future cash flow are discounted back to the present using a discount rate that reflects the time value of money. Internal rate of return. The internal rate of return is the effective interest rate that results in an NPV of 0. Behavior aspect of change. The behavioral aspect of change are crucial because the best system will fail without the support of the people it serves. Organizations must be sensitive to and consider the feelings and reaction of persons affected by change. Why behavior problems occur? To minimize adverse behavioral reactions, one must understand why resistance takes place. Some of the more important factors include the following. Fear. People fear the unknown, losing their jobs, losing respect or status, failure, technology and automation, and the uncertainty accompanying change. Top management support. Employees who sense a lack of top management support for change wonder why they should endorse it. Experience with prior change. Employees who had a bad experience with prior change are more reluctant to cooperate. Communication. Employees are unlikely to support a change unless the reasons behind it are explained. Disruptive nature of change. Requests for information and interviews are distracting and place additional burdens on people, causing negative feeling toward the change and prompt them. Manner in which change is introduced. Resistance is often a reaction to the method of instituting change rather than to change itself. Bias and emotion. People with emotional attachment to their deities or co-worker may not want to change if those elements are affected. Personal characteristic and background. Generally speaking, the younger and more highly educated people are, the most likely they are to accept change. How people resist change. Major behavioral problems often occur when the new system is implemented and the change becomes a reality. Resistance often takes one of three forms: aggression, rejection, or avoidance. Aggression is behavior that destroys, cripples, or weakens system effectiveness, such as increased error rates, disruption, or deliberate sabotage. Projection is blaming the new system for everything that goes wrong. The system becomes the scapegoat for all real and imagined problems and errors. Avoidance is ignoring a new AIS in the hope that the problem, the system, will eventually go away. Preventing behavioral problems. The human element, which is often the most significant problems a company encounter in implementing a system, can be improved by observing the following guidelines. Obtain management support, meet user needs, involve user, allay fears and stress new opportunities, avoid emotionalism, provide training, re-examine performance evaluation, keep communication lines open, test the system, keep the system simple and humanize it, control user expectation. System analysis. When a new or improved system is needed, a written request for system development is prepared. The request describes the current problems, the reason for the change, the proposed system objective, and its anticipated benefit and cost. Here are the steps in system analysis. There are initial investigation. Wait a moment. Here are 5 steps, like initial investigation. Objective: investigate each development activity to define the problem to be solved. Then system survey, then go to feasibility study and information needs and system requirements, and the last, system analysis report.
System design, implementation, and operation. Evaluate design alternative. The following standards should be used to evaluate design alternative. 1. How well it meets organization and system objective. 2. How well it meets user needs. 3. Whether it is economically feasible, and 4. How advantage weighs against disadvantage. Figure 22.1. This is conceptual system design activities. Prepare design specification and report. Once a design alternative is selected, conceptual design specifications are created for the following elements. 1. Output. Because the system is designed to meet user information needs, output specifications are prepared first to evaluate store sales as a must design. A. How often to product a sales analysis report? B. What the report should contain. C. What it will look like, and D. Whether it is a hard copy or screen, or both output. 2. Data storage. Data storage decisions include which data element must be stored to product the sales report, how they should be stored, and what type of file or database to use. 3. Input. Input design consideration include which sales data to enter, sales location and amount, and where, when, and how to collect the data. 4. Processing procedure and operation. Design consideration include how to process the input and storage data to produce the sales report and is in which sequence the process must be performed. A conceptual system design report summarize conceptual design activities, create practical design activities communicated how information need will be met and help the steering commit as assess feasibility. In Figure 22.2, show the physical system design phase that are described below in detail. Output design. The objective of output design is to determine the natural format, content, and timing of report, document, and screen display. Output usually fits into one of the following four categories. First, schedule reports have a prescriptive content and format and are prepared on a regular basis. Examples include monthly performance reports, weekly sales analysis, and annual financial statements. Two special purpose analysis reports have no prescriptive content or format and are not prepared on a regular schedule. They are prepared in response to a management request to evaluate an issue, such as which of the new product would provide the high profit. 3. Triggered expectation reports have a prescriptive content and format but are prepared only in response to about abnormal condition. Excessive absentees, cost overruns, inventory shortages, and situations requiring immediate corrective action trigger such report. Fourth, demand reports have a prescriptive content and format but are prepared only on request. Both triggered expansion reports and demand reports can be used effectively to facilitate the management process. Output design. Designs often prepare simple output and ask users to evaluate whether they are complete, relevant, and useful. An acceptable output is modified and reviewed again as many times as necessary to make it acceptable. To avoid expensive time delays later in the SDLC, many organizations require users to seek a document stating that the output format and content are acceptable. Field and database design. Data in various company units should be stored in compatible format to help avoid the problem AT&T Page 23 business unit a jumble of incompatible system and data format and inability to communicate and share data with other units. AT&T spent 5 years creating a single view of its customers so customers' data could be shared across business units. Input design. Into the same consideration include what type of data will be input and the optimal input method. Format design, although a system are moving away from paper document and toward source data automation, aus- automation form design is still an important topic. Computer screen design it is more efficient to enter data directly into the computer than into paper for subsequent entry. Input design. Computer input screens are most effective when these procedures are followed. 1. Organize the screen so data can be entered quickly, accurately, and completely. Minimize data input by retrieving as much data as possible from the system. For example, entering a customer number could cause the system to retrieve the customer's name, address, and other key information. 2. Enter data in the same order as displayed on paper form that capture the data. 3. Group logically relate data together, complete the screen from left to right and top to bottom. 4. Design the screen to user can jump from one data entry location to other or use a single key to directly to screen location. 5. Make it easy to correct mistakes. Clear and explicit error messages that consist error all screen are essential. There should be a help feature to provide online assistance. 6. Restrict the data or the number of menu options on a screen to avoid clutter. Program design. Program development one of the most time-consuming SDLC activities that take place in the 8 steps shown below. First, determine user needs. System analyze, consult with user and reach an agreement on user needs and software requirements. Second, create and document a development plan. Third, read program instruction or computer code. Program preparation time may range from a few days to a few years, depending on program complexity. Fourth, test the program, debug in the process of discovering and eliminating program errors. 5. Document the program documentation explains how program works and is used to correct errors. 6. Train program use. Program documentation is often used to train users. 7. Install the system or system components including the program and the hardware are combined and the company began to use the system. 8. They use modify the system factor that require existing program to be refreshed to as program maintenance include requests for new or revisit reports, changes in input file contents or values such as text read, error detection, and conversion to new hardware. Procedure and control design. Procedure should cover input preparation, transaction processing, error detection and correction, control reconciliation of balance database access, output preparation and distribution, and computer operator instruction, procedure documentation, and training might take the form of system manuals, user instruction quests, training materials, or online help screen. The ethical creep-in, creep-out implies that improperly controlled input, processing, and data storage function product unreliable information control must be built into an AES to ensure its effectiveness, efficiency, and accuracy that should minimize errors as well as detect and correct them when they occur, accounted by a vital role in this area. System samples, sorry, system implementation. System implementation is the process of installing hardware and software and getting the AES up and running. Implementation planning and seed preparation and implementation planning consists of implementation takes expected completion date, cost is estimation, and who is responsible for each task. The plan specific when the project should be complete and when the AES is operational. The implementation team identifies factors that decrease the likelihood of successful implementation, and the plan contains a strategy for coping with each factor. Seed preparation is a lengthy process and should begin well in advance of the installation data. Figure 22.3. This is system implementation and conversion. Selecting and training personnel. Employees are hired from outside the company or transferred internally, which often is the less costly alternative because they already understand then from business and operation transferring employees who are displaced because of the new system could boost employees' loyalty and morale. When users are not adequately trained, the company will not active the expected benefit and return on its investment. Companies provide insufficient training because it is time-consuming and expensive. The hidden cost of inadequate training is the user turn for the help to co-work who have mastered the system, decreasing the productivity of co-work and incurring company costs. Employees must be trained on the hardware, software, and any new policies and procedures. Training should be scheduled for just before system testing and conversion. Many training options are available, such as vendor training, self-study manuals, computer assist instruction, videotape, personal presentation, role-playing, case studies, and experimenting with the system under the guide of experienced users. Complete documentation. Three types of documents must be prepared for new system. 1. Development document describe the new AES It includes a system description composed of output, input, and field and database, like out program flowchart, test result, and user acceptance form. 2. Operation documentation includes operation schedules, fields and database access and equipment, security and field retention requirements. 3. User documentation teach user how to operate the AES. It includes a procedure manual and training material. Testing the system. In the Kuwait system, testing was another reason for the Blue Cross and Blue Shield system failure. The development underestimate system complexity and promise an unrealistic delivery time of 18 months. One shortcut they took to meet the deadline was to deliver an understood system. Document and reports, user input control, operating and processing procedure, capacity limits, recovery procedure, and computer programs should all be tested in realistic circumstances. Following are their common form of testing. One walkthrough are step-by-step reviews of procedure or program logic to find incorrect logic, error, omission, or other problems. 2. Processing test data including all valid transactions and all possible error conditions is performed to determine whether a program operates as designed, that is valid transactions are handled properly and errors are detected and dealt with appropriately. 3. Acceptance tests use copies of real transactions and fields rather than hypothetical ones. System configuration. Configuration is changed from the new AES. Many elements must be configured: hardware, software, data file, and procedure. The process is complete when the new AES is a routine ongoing part of the system. For configuration approaches are used. One direct configuration terminates the old AES when the new one is instruction attempting a direct configuration. 2. Parallel configuration operate the old and new system simulation. System simultaneously for a period. 3. Pilot configuration implement a system in one part of the organization, such a branch location. System configuration. Data configuration can be the consuming, tedious, and expensive. Its difficulty and magnitude are easily underestimated. Data fields might need to be modified in the first field might be moved to a different storage medium. For the example, from the types to this second, data content might be changed. For the example, field and record might be end or delete. Their field or database from may be changed. The first step in the data configuration is to decide which data fields need to be configured. The data are changed for complete completeness and error and inconsistent are removed. Following data conversion, the new fields are validated to ensure data were not lost during conversion. If data conversion is lengthy, the new fields must be updated with the transaction that occurred during data conversion. Once the fields and database have been converted and tested for accuracy, the new system is functional. The system should be monitored for a time to make sure it runs smoothly and accurately. The final activity is to document the conversion activities. Operational and maintenance. The final SDLC step is to operation and maintain the new system. Control of the AES is based to the data processing department, but work on the new system is not finished. Over the life of a typical system, 30% of the work takes place during development and 70% is spent on software modification and update. Summary and case conclusion. Unquestioned takes the sales processing system first. They give the project development team her system analysis report and the company data during conceptual system design. The time visiting stories with similar. Okay, that's all. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.